So I'm going to ask you guys, if they've told us it's a parallelogram, can we use the properties of a parallelogram in this question? Yes or no? That's yes. Murula, absolutely. Yes. And Zalo, we can't say no here. We have to say yes because they've told us that it's a parallelogram. So yes, we can. We can use the properties of a parallelogram. But I want you guys to note that they say here, show, and show is the same as prove. Prove that ABCD is a rectangle. Prove that it's a rectangle. Now, because we are proving that it's a rectangle, can we use the properties of a rectangle to prove that it's a rectangle? Yes or no? No, good. Okay. Now we're seeing the difference. Okay, I do want you guys to remember that a rectangle is a parallelogram. It just has extra features. Okay, a rectangle is a palm. It just has extra things. So what we can use to prove this parallelogram is only the things that a parallelogram and a rectangle have in common, not just the properties of a rectangle, only the properties of a parallelogram that the parallelogram and the rectangle have in common. All right, so where do we start? Does anybody have any idea? How would we possibly start this kind of question? Okay, I'm going to remind you guys before we even go anywhere that quadrilaterals or quads are made up of what? What are they made up of? Who knows? Who remembers from Monday's lesson? What are they made up of? Yes, Nzalo, absolutely. Yes, they're made up of triangles, but they're made up of a special type of triangle. There are two triangles in particular. What do we want those triangles to be? Ooh, not scalene and isosceles. Remember, it's two triangles together, and we need those two triangles to be what to each other? Not equilateral, guys. Ah, ovio, that's it. Beautiful. We need them to be congruent. That's it. Congruent triangles. Quadrilaterals are made up of congruent triangles. Most of them are. The irregular ones, not so much, but these regular ones like your rectangles and your parallelograms and your kites, they are normally made up of congruent triangles. All right, so we're going to then look for the two congruent triangles that we can use in this particular example to get to the answer we want. So I'm going to map them out like this. I'm going to go triangle A, B, oh, A, D, B. So I'm going to start, I'm going to say in triangle A, D, B, and triangle. Now, I want you guys to note how I've mapped this out. I started at the corner and I went past the long side and then down the middle to finish off my triangle. I want you guys to give me the other triangle, please. What would the other triangle be called? Triangle what? Start at the corner and go past the long side. Start at the corner, Samuel. Start at the corner. It's not going to be the corner at the top, guys. Which corner is it going to be? That's it. Ovayo. Ooh, Ovayo, you are on fire today. That's it, part 2. Beautiful. I'm going to start at this corner over here, C, and I'm going to go past the long side and then down up the middle and then finish my triangle off. So it must be triangle C, B, D. And part 2, I think it was you on Monday who was like, ma'am, is the order of the triangles important? Do we really have to write it if they've already given us the triangles? Yes, because in this case, they didn't give us the triangles that we need. So we need to figure out what those triangles are going to be. So it's very important that we know how to do this. Okay. Was it not you? Okay, it's okay. Whoever it is who asked, I forget who it was, but I know you understand. I know. Okay. Okay, good. That's okay, my sweetie. I'm not picking on you. You haven't done anything wrong. Don't stress. Okay, Cool. All right. Now, I want us to think of the fact that these two triangles put together have some properties of parallelograms, guys. What properties of parallelograms do we know? And use this particular triangle that we've got to give me those properties of parallelograms. Anybody? Good. AD is equal to BC. Well done, Amber. Hi, Amber. Okay, good. Our first thing is that AD is equal to BC. And we know that this is the properties of a parallelogram because the property of a parallelogram says that our opposite sides are equal. Opposite sides equal. Right. Anything else? Good. AB and DC are equal. Thank you, Asbonge. I'm going to check on Remo. Your statement, I think, is also correct. I'm just going to write down this one quickly. AB is equal to DC. Good. That's also the properties of a palm. And we know that because the opposite angles are equal as well. Properties of a palm. And we can just say opposite angles are equal. Good. AC is not common in this case. Amber, be very careful. Which side is common? Which side is common? Look at your triangles. Which side is common? Yes, good, Mirula. AC bisects DB, but that's not going to help us in the triangles that we're looking for. Good, good. BD is common. Excellent. BD is common. Right, but we've already got our three things, guys. We know that this is a side, and BD is a common side. Therefore, triangle ADB is congruent to triangle CBD. What is our reason? Tell me, what is my reason, guys? Good, side, side, side. I feel like my internet connection is a little bad today. Don't know what's going on. Okay, yeah, it's very weak. All right, good. So now that we know that this side is equal to that side, right? Let me just draw it properly, actually. This side is equal to that side, and we know that that side is equal to that side. What do you guys think would be the clenching property that would prove that this is a rectangle? Which property would we really have to nail about rectangles to find out which one is a rectangle? No. Okay, we know that it's a parallelogram. Jasmine, what is the one thing that we would need to prove to make sure that it's a rectangle?
Are the angles?
Good. The angles are what? How much should each of the angles be?
All the angles should be 90 degrees.
Absolutely. 100%. I love to see it. Good. We know that all of our corner angles must be equal to 90 degrees. Well done. Well done. Excellent. Beautiful. So that's the next thing we're going to prove here. Okay, that's what we're going to prove. All right, beautifully done. Right, we're going to prove that they're 90 degrees because as soon as we've proven that they're 90 degrees, that automatically makes this a rectangle. Okay. All right, so what we can do here, guys, is we can use the idea that we know that angle A must be equal to which angle? Angle must angle A be equal to that. Remember to stay on mute, guys. Good. Angle A must be equal to angle C. And we know this because we've just proven that property. Remember that CPCTC we like to talk about? Congruent properties of a congruent triangle are congruent. If we can prove that the triangles are congruent, then that automatically means that all the properties of it going around are congruent as well. So CPCTC, or you could easily just say, guys, you can say that triangle ADB is congruent to triangle CBD. You can use either of these, and you should just double check with your teachers, guys, which reason they prefer. Okay, because I know that some teachers, I've just found out from the other teachers at Watobe that they prefer the second reason over the first, even though both of them are correct. Okay, so just make sure you're double checking with your teacher. Good. So we know that angle A is equal to angle C. We've just looked at that. Okay, good. These two angles are equal. Good. But we also know that they should be more. And if they don't, then you can just ask them to look it up. Okay, most of them will be like, oh, yes, I know what they mean. Okay. All right, now if we use the fact that we know that AC or A and C are equal to each other, look at what's going to happen over here, guys. We know that angle D will be equal to angle B, but we also know that angle B will be equal to angle D, right? So it's the same thing in both triangles, right? We also know that angle B will be equal to angle D, right? Again, CPCTC. But if those two angles are equal to each other on both fronts, that means that put together, they are also going to be equal to A and C. Am I making sense, guys? Okay, what I mean is, if I know that, okay, here's what I mean, Asbonge. If I know that angle, because remember, these over here are parallel to each other. If I know that angle D2 will be equal to B2, and I also know that angle B1 will be equal to angle D1, if this part of each of the triangles is 90 degrees, if I put these two together, how much do they need to give me? Good. That's it. They need to give me 90 degrees because the whole of angle D is equal to angle B, and the whole of angle B is equal to angle D. Does that make sense? Right. So, okay. So what I mean is, in this triangle, if these two together will give us 90 degrees, yes, they'll give us 90 degrees because this angle over here is 90. So together they will give us 180. If this one is already 90 degrees, then those two equal 90. But if that one is equal to that one, and that one is equal to that one, that means this corner over here, what angle must I get at this corner over here, guys? How much must that corner also be equal to? That's it. It must also be equal to 90 degrees. So what that tells me is that angle A is equal to angle B, which is equal to angle C, which is equal to angle D, because they are all equal to 90 degrees. That is the property that we are trying to prove. Give me a thumbs up if what I've just done makes sense. Excellent. Now that we know this, and we also know that because they're all equal to 90, they're going to make up the interior angles of a quad. They're going to make up the interior angles of a quadrilateral, but not just any quadrilateral. We know that. That means, therefore, that ABCD is a rectangle. Okay. All right, excellent. And that's how we would solve for this particular question. All right, if I haven't done this justice, please let's come back to it at the end of the lesson and we'll look at it again. All right, so you can just type in the chat, ma'am, please come back to it at the end, and I'll come back to it at the end of the lesson. All right. All right, guys. Okay, let's get started on today's work, which is pretty simple. We're just going to be looking at analytical geometry. On a scale of 1 to 10, how comfortable are we with analytical geometry? Patu says 15. Remo says, never seen that before. All right. Okay. Sibusiso's at a 6. That's okay, Remo. We're going to explain. It's not difficult at all in this case. Oh, but some of the questions that we're going to do today might be a little bit difficult. Okay, Yandre is at a 9. Okay, Yandre, that's fine. That means we just I need to see how we're going to get that 9 to a 10. Mutla's at a 5, Twanilo's at a 6. No worries, guys. All right. Imelda, where did the 0.2 go? Where did the 0.2 go? Oh, no. Okay. All right, guys. So everybody, before we get started, I need you guys to take a screenshot of these formulas. Okay. Take a screenshot because you're going to need them. We all know this, and we should probably already know these off by heart. Okay, but we're going to need them today. So take a screenshot. You've got 5 seconds. And I'm afraid to count down because Teacher Nelly is going to start dancing. Okay. All right, let's get started, guys. Let's get started. All right. I'm going to skip this question because I think this question is quite easy. So we're only going to do question A, and then we're going to move on to the next one. All right. So I want us to make sure that everything that they've given us, guys, that's mentioned over here is on our drawing. Now it says here, in triangle ABC, A is 4 and 6. Yep, they gave it to us in the drawing as well. B is X and Y. Aha, we don't have any values for X, Y for B, so we're going to have to find those. C is -4 and -6. Okay, yes, Asbonge it is, but we don't use it in grade 10. It's only a grade 11 concept, right? And then they say to us that point P, is the midpoint. That is very, very important. It's the midpoint of AB. So this point over here, P, is the midpoint of AB. All right. Now, the first question, which is the only question we're going to answer, we're not going to do B or C. We're only going to answer A. They say, calculate for the coordinates of point B. Who knows? Anybody got any idea what we would do in this case? Yes, Mirula. No, don't go away. Come back. What would you do? Meerkat, come back. Hello.
Would you use midpoint?
Absolutely, we would use the midpoint. Excellent. But what do we notice about this midpoint here? What have they already given us from the midpoint? What is this?
It's the midpoint of A and B.
Good, it's the midpoint of A and B. So these are the answers, right?
Mm-hmm.
That's what we're looking for. So I want you to put this into the midpoint formula for me. All right, give me the midpoint formula. Let's start there. What is the midpoint formula?
X1 plus X2 over 2.
Good. And?
Y1 plus Y2 over 2.
Beautifully done. All right. So now that they've given us the answer, we know that the midpoint of AB, right? Let's name these quickly. This one is X1 and this is Y1 and this is X2 and Y2. We're just going to substitute. What is my X1 value?
4.
4, good. Plus my X2 is just
X2.
Just X2, good, over 2. And all of this must be equal to how much? Remember, they've given
5.
me my answer. Good, it must be equal to 5, good. Right, and on the other side, we're going to do the same. Give me my equation.
6
Mm-hmm.
plus Y over 2 equals 1.
Good. Beautifully done. All right, what's my next step?
You times it by 2, both sides.
Good, we're going to times both sides by 2, times by 2, times by 2, times by 2, times by 2. Excellent. What's my next statement? What will it look
And
like?
then we just leave the X alone by minusing the values.
Good. Okay, you're going to skip a step. If we don't do that step, we need to make sure we're doing it. All right. So if those 2 has canceled, what do I have left on this side?
X and Y.
Not really. Remember up top here, I've got 4 plus X, right? 4 plus X. And this needs to equal to how much?
10.
10. Beautiful. Good. And then over here, I've got 6 plus Y, and 6 plus Y must equal to?
2.
2. Excellent.
Yeah, yes.
Now we can transpose, right? Okay, now you can solve for x for me.
6, x equals 6.
Good. X is equal to 6 and y is
And
equal to?
-4.
Beautifully done. Excellent stuff. So my coordinates for B are 6 and -4. Very well done, my dude. Excellent. I think it's the eyebrows and the mustache that are just feeding your mathematical ability at this point, because I see them in every lesson now. I feel like it's a superpower that you just happen to put on.
I don't know how to turn it off.
Oh, I'm sorry. I'm sorry. I'm sorry. It looks cool though. It looks cool. Sorry. We'll find out for you, Shane. I just don't ever do that to your actual face, Murula. Let's just leave it at that. Okay. Do not ever dye your eyebrows white and your mustache orange. That's all we're gonna say. All right, give me a thumbs up. Okay, please give me a thumbs up if you understand how we got to the answer. Okay, excellent. Remo, those tears, I don't want them to be on your face. So I'm going to need you to like raise your hand if I've lost you somewhere and make sure we don't leave you behind. I don't want to leave you behind. Okay. Excellent, guys. Awesome. All right. Good stuff. All right, let's look at our next question. Right, look at question number 5 over here. It's kind of hidden, but I want you guys to read it here. It says here, determine 2 possible values of x if AB is equal to the square root of 185 units, and A is the 0.46 and B is the point x minus 5. Right, what do we know that where did they get this square root of 185? From which formula did they find that square root of 185, guys? That's it. Good. They found this from the distance formula. Excellent. This is from the distance formula. Good. So we're going to have to use the distance formula here. And we know that we need the 2 points in order to find that. Now, we know that the distance formula, AB, is going to equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. All right, I'm going to give you guys the next 4 minutes because this one is a bit of a challenging one. I'm going to give you guys 4 minutes to find me the 2 values of x. And the reason we know we're going to get 2 values of x is because this x thingy over here is squared. Okay, if you are stuck, I want you to just write in the chat, ma'am, I am stuck. Okay, when you get to a certain point. If you don't even know where to begin, also write in the chat, ma'am, I don't know where to begin. So at least I know how slowly I'm going to have to explain this question. But for those of you who know exactly what's going on, go ahead and answer the question for me. Pop your favorite emoji in the chat when you're ready. Okay. Give you guys some hints as we go along. I'm going to name this x1 and y1, and we're going to name this x2 and y2, right? What's that? No hints. Okay, so. But it wasn't really a hint, Patu. I just named them for you. Sorry. Okay, Amache, I want you to hold on for me, my sweetie. What I want you to do for now is write down the distance formula. Okay, so I'm sorry for that. Sorry, Patu. Next time I won't give a hint. Okay, Amache, write down that AB is equal to the square root of x squared minus y x1 minus x2 all squared. Okay, that's okay, Twanelo. I want you guys to just write down the distance formula, and then we're going to take it slowly together. Okay. All right, guys, I'm going to call it. That's time. For those of you who are still busy, Mirula just finished. Okay, for those of you who are still busy, continue very quickly. The rest of us are going to just come into it slowly, and you can check as we go along to make sure that you've gotten the answer that we're looking for. All right, so I know that the AB over here, they've told me that AB is 165, the square root of 165. So I'm going to replace AB with the square root of 185. That's the first thing I'm going to do. I'm going to go the square root of 185 is equal to the square root of, and then we're going to go in here, and my x2 value is x. So I'm going to go x minus my x1 value is 4. So x minus 4 all squared plus my y2 value is negative 5 minus y1, which is 6 all squared. Right, now I'm just going to clean up this thing underneath the square root very quickly. So I'm going to get the square root of 185 is equal to the square root of, there's no way for me to clean that up. So I'm going to leave it the way it is. X minus 4 all squared plus negative 5 minus 6 will give me negative 11 squared. Right, now guys, how do I get rid of this square root? How do we get rid of a square root? Because I want to solve for the thing underneath the square root. So what do I need to do to get rid of the square root? That's it, Samuel. Good stuff. Awesome, awesome, awesome. That's it. The way we get rid of a square root is we square. Right. So I'm going to square this side, but what I do on the right-hand side, I'm going to have to do on the left-hand side as well. I'm going to square over here. So this square root will also disappear. Right. So the square root will cancel out with the square. Same on this side. The square root will cancel out with a square. So I'm going to have 185 is equal to x minus 4 all squared plus, I know that the negative 11 all squared will give me 121. Now, let's look at this thing inside the square root over here. This is x minus 4 all squared. What do we need to do with this x minus 4 all squared, guys? I can't just distribute the x, the squared to the x and the 4, no? What do we know this as? X minus 4 all squared, it's good, Patu, that's it. It's a double expression, right? It's the same thing as x minus 4 times x minus 4. So that's what we need to do here. We need to do a FOIL. We need to do FOIL. And if I do FOIL, what I'm going to have left is 185 is equal to x squared minus 8x plus 16 plus 121. Right, 121. Now, the thing that I notice is that because I have an x squared, this is going to turn into a quadratic. So I need to solve it as I would a quadratic equation. Now, what I would do is I would take 185 over to the other side and I'd leave a 0 on this side. Okay, so I will take this 185 over to the other side and I will get 0 is equal to x squared minus 8x plus 16 plus 121 minus 185. Somebody punch that into a calculator for me. These ones here, these like terms. 16 plus 121 minus 185, how much will that give us? Pop your answer in the chat for me. 0 is equal to x squared minus 8x. Be careful, Asbonge. We're not adding them all together. 16 plus 181 minus 185 will give us minus 48. Good. Now what I'm going to notice is that I've got a quadratic, so I'm going to open two brackets. 0 is equal to, open two brackets, x here and x there. I know that this is a minus over here, so my signs will look different. So I'll put a plus here and a minus there. I need factors of 48 that are going to give me negative 8, guys, when minus from each other. Anybody got any ideas? Factors of 48, guys. Anybody? Or you can just punch this into your calculator and get an answer. Good. All right, CJ, yes, that's one of them. Good. Negative 12 over here. So 12 times what will give us 48, guys? That's it. Good, CJ. Yo, CJ, excellent job. Well done. Right. Good. And now that I've got my two quadratics, I can then say x plus 4 is equal to 0, or x minus 12 is equal to 0. Therefore, x is equal to negative 4, or x is equal to 12. Whew, Anna, this is beyond late, but we're glad to see you either way. All right. Okay, I'm going to ask you guys, scale of 1 to 10. How difficult was this question for you? 1 being, yeah, it was okay. And 10 being, yo, ma'am, I don't know. How difficult was this question? Okay, Remo says 8. Sihle says 0. I think Sihle got all the correct answers. Okay. Zama says 8. Nyeleti says 7, 9, 0,1. Okay. Asponge a 9. I will. Samuel, 10 and more. Was it very difficult? I didn't think it was. This is the go-to question, guys. In these questions. Yeah, it's free marks, dude. It's free marks. Yeah, it's not that difficult as long as you know the steps and you understand exactly what it is that's happening. All right. Okay, let's look at this next question that's coming up. All right. Question 9 over here says, SUVT is a parallelogram. So they tell us that it's a parallelogram, guys, right? They tell us that it's a parallelogram. So yes or no? Can we use the properties of a parallelogram? Yes or no? Anna, the correct answer is yes, because they tell us that it is. It is a parallelogram. So yes, we can use the properties of a parallelogram. Okay, if they said prove that it's a parallelogram, we won't be able to use those properties. All right, and they give us the vertices S, T, U, and V, and then we notice very quickly that V does not have any values. V is X, Y. Okay, now it says, find the coordinates of V by using the fact that the diagonals of a parallelogram bisect each other. What does that tell me, guys? What does that tell me when they say that the diagonals bisect? What does that mean? Who knows? What does that tell us about this point where they bisect? What would we know this point as? Yes, Patu, absolutely. That's it. Now I have to ask you guys, this midpoint that you guys are talking about, is it the midpoint of SV or is it the midpoint of TU? Which one is it the midpoint of? Yes, absolutely. Good. Yeah, Remo, it's not a question. It's not both question mark. It's both full stop. Point period, point blank period. It is the, yes, that's it. It was a trick question, Mirula. It is the midpoint of both. Right. So if we can find the midpoint, which 2 points are we then going to use to find the midpoint, guys? Good. Thank you. Thank you, Remo. Good. Which 2 points are we going to use to find the midpoint? That's it. Patu, excellent. Nyeletu, that's it. That's it. Beautiful stuff. We're going to find the midpoint of TU. And the reason for that is because we know that the midpoint of TU is equal to the midpoint of SV. And then we can use the fact that we've got the midpoint to find the values of, or the X and Y coordinates of V. I'm going to give you guys 4 minutes. In fact, I feel like 4 minutes is a lot. Okay. Use these 2 things. Pop your favorite emoji in the chat when you're done, and we can talk about the next question in a bit. All right. Go for it, guys. 2 more minutes, guys. Sure, Asbonge is done. Sure. Those brains are working super fast. Well done, Sihle. Nice one, Samuel. Well done, guys. 30 more seconds. Imelda, I don't know why the bed? Why the bed? Nice one. All right, guys, that's time. All right, let's look at this question here. Okay, so we're going to solve for the midpoint of TU. And we know to find the midpoint of TU, we're just going to do x1 plus x2 over 2 and y1 plus y2 over 2. You can pick which one is x1, which one is y1. It doesn't matter which one is which. Okay, so I'm going to call this x1 and y1, and I'm going to call this x2 and y2. Right, so the midpoint of TU is going to be -2 plus 2 over 0. Over 2, over 2 and -1 plus 0 over 2. Right, so the midpoint of TU is equal to 0 and -1 over 2. Right, so those are my 2 midpoints. And I know that this is also the midpoint of SV. And I can use that property that we learned at the top so that we know that we've given ourselves the answer. So we know the answer and we just need to figure out what V is, right? The coordinates of V. So I'm going to name this one X1 and Y1. So I'm going to go that the coordinates of V will be X1 is -1 plus X, we don't know what that is, over 2 must equal to 0. And y1 is 2 plus some y that we don't know over 2 must equal to -1/2. Right, so in order to solve for V, we'll go V, which is multiply by 2 on both sides, times 2 times 2. Those 2 will cancel. I will get -1 plus X is equal to 0. And over here, times by 2, those 2 will cancel. I will get 2 plus y is equal to -1. -1/2 times 2 is -1. Right, that will go over to that side. Therefore, I'm just going to carry on over here. X must be equal to +1, and my y must be equal to -1 minus 2, which is -3. So my coordinates for V would be 1 and -3. Give me a thumbs up if you got this one correct. Did we manage to get this one? Amazing stuff. Well done, Mirula. That's it. Well done, guys. Amazing. Awesome, awesome, awesome. I told you the properties of quadrilaterals are going to come back to haunt you guys. They're going to keep coming back. So we can't pretend that they're not going to be there. They're going to keep coming. All right. Okay, for those of you who didn't quite get 100% on this question, I hope you're seeing the way that we're doing. Let me know if there's anything I need to explain again. All right. Okay, let's look at this next question. I'm going to skip that one. I'm going to go to that one. Now, let's look at question 11. Question 11 says, prove that ABCD is a parallelogram. Now, look at what they've given us, guys. They've given us a quadrilateral, and all they've given us is coordinates. Does anybody think they can venture for us which property of a parallelogram we're going to use here, or which properties of a parallelogram we can use in order to find or in order to prove that this is a parallelogram? Now, before we even go there, I'm going to ask you guys again. Can we use the properties of a parallelogram to prove this? No, good. That's the correct answer. No, we cannot use the properties of a parallelogram in order to solve for this. We need to look at other things, right? We need to prove the properties of a parallelogram. Good. Now I'm seeing a couple of examples. Good, saying that the gradients of parallelogram of parallel lines are equal. Beautiful, Tyrika. That's wonderful. So we know that the gradient, because these two lines are they should be parallel. If we get that the gradient of CD is equal to the gradient, small m, small letter m, teacher Coco. Good. If we get that the gradient of CD is equal to the gradient of AB, that will then prove that they are in fact parallel. Good. Excellent. I like that suggestion. Good. Patu, when you say bisecting, what do you mean by bisecting? Good. Lesedi also says opposite sides are equal. So we can look at the distance formula. We can see if the distance of AB is equal to the distance of CD, if these two things are equal, and if the distance of AD is equal to the distance of BC, then that indeed will show that the opposite sides are equal. Right. Good. That's it, part 2. We know that if they bisect like that, and there's a middle point in a parallelogram, we know that the midpoint of AC will be the same thing as the midpoint of BD. Right. So all of these are the different ways that we can possibly prove for this to be a parallelogram. I want everybody to pick one. Pick one. Okay. And I want you to go solve for it. And then I'm going to take some suggestions to see who got the correct one. You can use the fact that CD needs to be parallel to AB. And then, oh, this one also. And the gradient of AD also needs to be equal to the gradient of BC. At this point, I'm thinking Patu's one might be the easiest because you only have to do 2 calculations and everybody else's one requires 4 calculations. Yes, they need to be parallel and equal. Very true. You can use the distance. Yes. Marula, remember the distance formula is this one. The size of AB must equal to the size of CD, and the size of AD must equal to BC. So the opposite sides will be equal. Okay, so pick one, guys, and you can then tell me which one it is that you've picked and whether it was in fact, if it actually did in fact prove that. Okay. Thank you, Teacher Nels. That is in fact correct. Okay. I think we've actually run. Sorry?
I have a question. If you're given such a question, how many characteristics do you need to use in order to be able to prove that it's a parallelogram?
Because it's a parallelogram, we must prove parallel, right? That's correct. We must first prove that either that they're parallel, right? Or that the opposite sides are equal to each other. Because even if it's a rectangle, it's still going to be a parallelogram. Even if it's a square, it's still going to be a parallelogram. Even if it's a rhombus, it will still be a parallelogram. So the other properties won't really matter as much. So you can choose whether you want to prove whether it's parallel or whether the opposite sides are equal. It won't really matter in this case. So you can choose one property. We just need to find that one property. Okay. So we only have to choose one. It doesn't matter whether it's a rectangle or a square or a rhombus. Won't make a difference. Okay.
But I feel like all the parallelograms have like, I think at least 4 characteristics that are similar, like for a rectangle, square, and rhombus.
They do. They do. So even if somebody, teacher knows, if somebody decides to prove, instead of doing that, if they decide to prove that these sides are perpendicular and it happens to be true that they're perpendicular, this means that they've proved that the shape is a rectangle, but that doesn't negate the fact that proving that it's a rectangle means that it's a parallelogram. Okay, so it doesn't matter which property we choose, as long as it's the property that that is present in all parallelograms. And in this case, whether it's a rectangle, a parallelogram, a square, or a rhombus, all of them must have parallel sides equal. All of them must have opposite sides equal. See, so whichever property they choose.
So general properties of parallelograms.
That's it.
Okay.
That's what we're looking for. General properties. So you don't have to prove all of them. You can just choose one of them that they all have in common. Okay. Cool. All right. It is actually 7 o'clock, and Asbonge says that Asbonge used the midpoint of BD and AC and said that the midpoint of both of them is midpoint of AC is equal to the midpoint of BD, and both of them were equal to 5/2 and 2. I will accept that answer. Very beautiful, because the diagonals bisect, and that means that each of the sides will be split evenly. So the side will be equal to this side, and that side will be equal to that side. And that proves it for me. That is, in fact, one of the properties of all parallelograms, that the midpoint must bisect them and cut them equally on each side. So Asbonge, 100%. That's a point to you. Anybody else, if anybody else has used any of the other properties, you're more than welcome to pop them in the chat. Unfortunately, we have run out of time. So teacher Nels, if you could just put the link to the quiz in the chat for me. You're going to be doing things like this. For any of you that would like a challenge, I'm going to show you a quick challenge question over here. There you go. You can write it down. Go and see if you can figure it out. It's not as difficult as it looks. It's not as difficult as it looks, I promise. Okay, just note that this is the midpoint of line ST, and they've given you the coordinates of S and T. So you're calculating for the midpoint of ST. So you're going to have to use the midpoint formula no matter what it is that you do. All right, let's see if anybody can get an answer for us on Monday. Midpoint formula, sorry.